So we've been talking about very simple hydrocarbon chains, but it is possible for us to have branches off of those chains, and that typically happens when you have an isomer. So let's go ahead and define isomers as they have the same molecular formula. So they have the same number of atoms of each element, but a different structural formula. And structural formulas are what we have been drawing when we draw our hydrocarbon chains. So a molecular formula is simply the actual number of atoms of each element, and it would look like C4H10. That's a molecular formula, where a structural formula shows how they're bonded, how they're arranged. So that would look like this. And then off of those, if I'm drawing the same thing, I need one more, like that. And then off of each of these would be hydrogens. So those are those definitions. So let me show you what I'm talking about a little bit. Whenever you see this N in front of it, we're going to be talking about this simple hydrocarbon chain. When you see the N, you can kind of ignore it and just draw what they've told you the name of. Bute, when we look in table P, right here, means 4. So I'm going to draw 1, 2, 3, 4 carbons. And then that ANE tells us that it is an alkane, and alkanes have single bonds between their carbons. So I'm going to draw single bonds between them. And then each carbon needs to have a total of 4 bonds. So off of each side here, we're going to have hydrogens. I'm going to let you in on a little secret, which I think I've told you before. Chemists are super lazy. And we assume when we're dealing in organic chemistry that if you see a line drawn for a bond and there's nothing written at the other end of it, that it's bonded to a hydrogen. They don't draw the hydrogens typically. They just leave those bonds kind of hanging out there, and you can assume there's a hydrogen there. I'm going to leave that up to you whether you want to draw them or not. Chemists don't draw them, so you don't have to. I can assume when there's nothing drawn at the other end of that bond that it is a hydrogen, and it'll save you a little time. So now what we're going to do is we're going to rearrange this. If I don't draw this yet, let me just draw one thing and show you how it works out. If I took my 4 carbons and I pulled off that end carbon and I stuck it off of one of the other carbons, let's say I thought if I drew it here, again, don't draw this, if I drew it here, that I would be making something with a different structural formula. And you're not, and let me show you why. These are all 3-dimensional, and they can kind of rotate on their bonds. So when you're trying to make something different, you can't ever put a little branch off of a terminal carbon. That's what we call the end carbons. Because look what happens. When I start at carbon number 1, and I just start numbering the ones that are attached to each other, this is still a continuous 4-carbon chain. It is not any different than the butane we drew in the first box. So this is not an isomer. So what we're going to draw instead, whenever you're making a branch, you're going to draw it off of an internal carbon. An internal carbon is one on the inside of the chain, because that will actually make it a different structural formula. So this will be a carbon like that. Now it's no longer a continuous chain of 4. We have a continuous chain of 3, and then we have this branch off of the side. Now we need to make sure that each of them has a total of 4 bonds by adding in hydrogens. And again, we said that if you don't draw the hydrogen, we can assume it's there. You do have to draw the bond though. So now, how are we going to name this? Well, typically what I like to do is start with my longest chain, and what I do is I put my pen down on a terminal carbon and just, without lifting it, connect as many carbons as I can without backtracking. So this is 3 carbons, but then I want to check and make sure that if I turned at that internal carbon that I don't get a longer chain. That's still 3 carbons. If I started from this end, 3 carbons, this end, still 3 carbons. So I'm going to name my longest chain, but I'm going to leave a little space, and I kind of drew into my name box. So if it has 3 carbons, according to table P, we would call that prop. So we're going to do prop and leave a little space ahead of that because we're actually going to put something in front of that. Oops, I went a little ahead here, and I added the ane because they are single bonded. That makes it an alkane. I can't change the bond type between the carbons because if I do, I'm going to lose hydrogens. So it might be tempting to make an isomer of butane by putting in a double bond somewhere, but you're actually going to end up changing the molecular formula, resulting in less hydrogens attached. Okay, I've now I've named my longest chain, but I've got to somehow indicate that this 1 carbon branch is hanging out here. That 1 carbon branch, since it's only got 1 carbon, we're gonna need the prefix meth. But I've also got to indicate that it's a branch. And what we do when we do that is we add a YL. So this will become methyl propane. And then it's not a bad idea, although in this case it won't matter, to give an address of that methyl, and I'm going to put a little dash between the 2 names. And the address of that methyl, you'll figure out, you always want it to be the lowest number possible. So you're going to check from either end or either terminal carbon. So I'm going to start here, and if I counted, this would be number 1, this would be number 2, and this would be number 3. So that would put my methyl off of my 2nd carbon. Let me try from the other direction. This would be 1, 2, 3. And again, it's off of my 2nd carbon. So I'm going to call this 2-methylpropane. In this case, because the chain is so short, the only way that you could have a branch would be off of the 2nd carbon. So you don't technically need that number or that address out front, but I wanted to show you how to do it because we are going to need addresses in the next one. It's not wrong if you include the address when you don't need it. I know that's different because we said if you included the Roman numeral in the name in the stock system of naming, you were wrong. So that's a little different. We're a little more lenient with organic stuff. It can get pretty complicated. All right, let's try the next one. We have pent, which means 5. 1, 2, 3, 4, 5. Ane, which means single bonds. And then we would need to put hydrogens off of each of them to make sure there's a total of 4 bonds. So now we have space to draw 2 isomers because there are actually 2 isomers of pentane for a total of 3 ways to draw pentane using the same molecular formula and different structural formulas. So the easiest thing to do when you're coming up with this is pull off one of the carbons on the end and stick it on an internal carbon. So we're going to start by doing that. So now instead of 5 carbon chain, I'm going to have a 4 carbon chain. And I'm going to take that 5th carbon here, and I'm going to draw it off of one of the internal carbons like that. And then make sure I have all my hydrogens. And this one's a bit more complicated, so I'm going to count my hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I didn't lose anything. So now we have to name this. So again, I would start with the longest chain. I'm going to write my name underneath just because I like a little more room. Move this out of the way. So 4 carbons is bute. They're all single bonded, so that's ane. and then that named this. I have a 1-carbon meth branch, so I put the YL, and then I should give that an address just to be sure that I know where to put it. And actually it doesn't matter in this case, but we're going to do it anyway. So if I were to number my carbons starting from the left, 1, 2, 3, 4, the address would be 2. You always want to use the lowest address possible. If I number from the other side, 1, 2, 3, 4, the address would be 3. So I'm going to use 2. 2-methylbutane. Now there's one more way that we can make a branch, and you have to be careful. You could still have this branch, but if you take this off and put it on this carbon, it's still part of that 4-carbon chain. So what we're going to do is we're going to take this end carbon off, but we're going to put it down here. And once again, I need to move this. So now I'll have a 3-carbon chain, like so. I'm still going to have that 1-carbon branch up here, but now I'm going to take this end carbon off, and I'm going to put it down below the same carbon the other branch is on. And now I'm going to go ahead and put in all my hydrogens. I'm going to count them just to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I didn't lose anything. Naming this is going to be a little tricky, but I'm going to start step by step. I'm going to name my longest chain. Try to make sure I have my longest chain. Okay, it doesn't matter which way I do it. It's going to be 3 carbons, so that's prop. They're all single bonded, so that's ane. And then I have, and this is pretty tricky for students, I'm going to call this my longest chain, which means that I have a 1-carbon branch here and a 1-carbon branch here. A lot of students want to add those two together and call that ethyl. But it's not ethyl. In order for it to be ethyl, the two would have to be attached directly to each other without crossing the main chain. So if I have to cross that main chain, it's 2 separate branches. So this is a 1-carbon branch, this is a 1-carbon branch. They're not attached to each other without crossing that main chain, so they're separate. That means that I have a methyl, and there's 2 ways you can do this. You can say methyl-methyl because you have 2 methyls, or you can just add di in front and call it dimethylpropane. Now because you have 2 branches, you should have 2 addresses. In this case, if you left them off, it would still be entirely acceptable because there's only one way for this to occur. But we're going to go ahead and put our 2 addresses on there so that we know for sure that there are 2. So the address for that center carbon is going to be, this is 1, this is 2, this is 3. So it's going to be 2. And I have to give 2 addresses because there's 2 methyl branches. So 2,2-dimethylpropane. And that's how you do isomers. We're going to practice with more of those in class, so hopefully you will get really good at naming and drawing all of them.